and welcome to this GCSE Science revision video for additional chemistry on quantitative chemistry, or the calculations that will come up in your additional chemistry paper. In this video we will look at calculating moles, calculating yield, empirical formulae, and analysing substances. Remember, the mass of an atom is made up by the number of protons and neutrons it has in its nucleus. Protons have a mass of 1, neutrons have a mass of 1. So therefore, the mass of an atom is the big number, the number shown at the top, or its atomic mass. Remember, the number of protons in a neutron is shown by the atomic number, which is the bottom number, which is always smaller. If we're going and looking at what 1 mole of an atom weighs, or an element weighs, it is made up of its atomic mass in grams. So for instance, carbon has an atomic mass of 12, so therefore 1 mole of carbon will weigh 12 grams. Oxygen has an atomic mass of 16, so therefore 1 mole of oxygen will weigh 16. The same can be done when working out how much 1 mole of a compound weighs. You start off by working out the compound mass. So in the case of carbon dioxide, you would take 12 as the mass of carbon dioxide, plus 2 lots of 16 for the mass of the oxygens, which would come to 44. So therefore, 1 mole of carbon dioxide would be 44 grams. Pause the video to have a go at working out the mass of 1 mole of methane and 1 mole of ethane. Because saying relative formula or atomic mass in grams is a bit clumsy, we simply say moles. So, if we are given a certain mass of a compound and you're asked how many moles it is, you simply work it out by taking the mass that you were given and dividing it by the mass of 1 mole of that compound. So, for instance, if we were told that we were given 100 grams of sodium hydroxide, how many moles is 100 grams of sodium hydroxide? We start off by working out the mass of 1 mole, which is 23 for the sodium, plus 16 for the oxygen, plus 1 for the hydrogen, which makes 1 mole 40 grams. Then we take the 100 grams that we've been given in the question and divide it by the mass of 1 mole, which is 40 grams, which gives us a total of 2.5 moles. So in 100 grams of sodium hydroxide, there are 2.5 moles. Pause the video and have a go at working out the number of moles in the masses of either the elements or compounds to the left hand side of the screen. When looking at chemical yield, we need to be thinking about the amount of product we actually make in reality in comparison to the amount of reactants that we use. There will always be some sort of loss of reactants in most chemical reactions due to reactants being lost, for instance, gases to the atmosphere, or not all of the reactants reacting together, or some of the reactants sticking to the equipment. To work out the maximum mass of a product, we use its chemical formula. We need to know this before starting to work out chemical yield. In questions about chemical yield, you take the mass that you've made and you divide it by the maximum mass of the product that could be made by looking at the chemical formula. This will give you some sort of figure that's in a decimal place, so to turn it into a percentage, you need to remember to times it by 100. Remember, when answering questions on chemical yield, write down your workings out, as if you make any mistakes, you might still gain some marks. Pause the video and have a go at the question in the yellow box below. Empirical formulae shows us the amount of atoms or the relative ratio of atoms in a compound. We can use the relative atomic mass of elements and the relative formula mass of compounds to find out its percentage composition. We need to work out the percentage composition of a compound before working out its empirical formula. We do this by working out the mass of the compound. We convert it into grams. Then for each of the elements in it, we go and work out its percentage. We do this by taking the mass of the element in the compound, then dividing it by the total mass of the compound. We then times it by 100. This gives us the percentage composition of a formula by the percentages of different elements within it. Pause the video and have a go at the question in the yellow box below. If we know the percentage composition of a compound, we can work out the ratio of atoms within it. This is known as its empirical formula. It might also be called its molecular formula in exam questions. To work this out, we divide the mass of each element by its relative atomic mass to find out the number of moles reacted. We create a ratio to simplify it when necessary, and using that ratio we go and write out its formulae. Pause the video and have a go at the question in the yellow box below. When looking at analysing substances, there are a few ways that we can do this. Paper chromatography is used to analyse coloured substances, such as coloured pigments in a plant or artificial colours used as food additives. Paper chromatography works because some of the coloured substances are better at dissolving in the liquid or solvent than others, so travel up the paper further. Instrumental methods of analysis rely on machines. There are several different types of instrumental analysis. Some are suitable for detecting and identifying elements, while others are better suited for compounds. In general, instrumental methods of analysis are fast, they are accurate, and they are sensitive. In gas chromatography, we allow a mixture of compounds to be separated. The gas chromatography machine consists of a long glass tube packed with a powdered solid material which is fitted into an oven. The tube is called the column, even though it's usually wound into a coil that it fits into the oven. We start off with the sample being dissolved in a solvent, then injected to the end of the column. An unreactive gas, usually nitrogen, carries the sample through the column. Different substances in the sample travel through the column at different speeds, and because they travel through at different speeds, they are detected at different points. The time taken to travel through the column is called its retention time. A detector produces a graph of each substance present by a peak. The number of peaks shows the number of compounds present in the sample. The position of each peak shows the retention time of each compound. A mass spectrometer is able to identify substances very quickly and accurately. It can detect very small amounts if the GCSE machine is linked to a mass spectrometer. This combined, called a GCMS method, allows the separated substances leaving the column of the gas chromatogram machine to be detected. The mass spectrometer can be used quickly to identify substances and is very accurately, as it can detect very small amounts. It can also provide the relative formula mass of the substances separated by gas chromatography. The peak furthest from the right in the mass spectrum is called its molecular ion peak. Its relative mass is the molecular formula mass of the substance being analysed. So remember, when revising, start early, use flashcards, don't get distracted, and good luck with your exam.